Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. Last year, a single mixed circle question on an exam cost more marks than any other geometry question across several boards. Students were well versed in individual rules, but the paper mixed them, and that caused panic. If that sounds familiar, you're not alone. In the next 12 minutes, I'll give you a single reasoning path that turns those scattered rules into one reliable method. Marks are there for the taking.
Section 1. The concept. Promise, we'll start from one idea, the angle in a semicircle, and show how that leads to angles at the centre, equal angles on the same arc, cyclic quadrilaterals, and the tangent radius right angle. By the end, you'll see these as connected consequences, not separate rules. Here's where the marks are. Understanding the chain of reasoning lets you state the correct theorem in exam answers instead of guessing.
Begin with the angle in a semicircle. Picture a diameter AB of a circle and any third point C on the circumference. The angle at C, subtended by the diameter, is a right angle. Why? Because the arc from A to B is a semicircle. It spans 180 degrees at the centre, and the angle at the circumference is half the angle at the centre. So angle ACB equals half of 180, which is 90. That idea, an arc of 180 at the centre gives 90 at the circumference, is simple but powerful. Say it aloud in your head. Diameter gives right angle.
From that single fact, we get angles at the centre and equal angles subtended by the same arc. If an arc subtends angle theta at the centre, it subtends half theta at the circumference. So if 2 points on the circumference see the same arc, they see equal angles. Practically, if points C and D both look at arc AB, angle ACB equals angle ADB. That's often written as angles subtended by the same chord are equal. But remember, it comes from the centre-circumference half relationship.
Next, cyclic quadrilaterals. If 4 points A, B, C and D lie on the same circle, then opposite angles add to 180 degrees. Why? Consider opposite angles at the circumference. Each subtends the arc made by the opposite 2 points. Since the two opposite arcs together make the full circle, the two angles together add to half of 360, which is 180. So angle A plus angle C equals 180. No magic, just add the two arc measures, half them, and you have the result.
Finally, tangent radius. The radius to the point of tangency is perpendicular to the tangent. You can see this from the equal angle idea too. The tangent makes an angle with a chord equal to the angle in the opposite arc. If you shrink that chord to the point where it becomes a radius, the angle tends to a right angle. A more exam-friendly statement is the angle between radius and tangent is 90 degrees. Stated, and when needed, give the small justification that the angle in the semicircle is 90 or that tangents make equal angles with equal arcs.
Worked example. Keep this short and exam style. Question. In circle centre O, AB is a chord and tangent at B meets the extension of OA at T. Angle ATB is 70 degrees. Find angle ACB, where C is the point opposite A on the circumference. Step 1. Draw the diagram and label O, A, B, C, T. Step 2. Mark known angles. Angle ATB equals 70. Step 3. Recognize relationships. The angle between tangent TB and chord BA equals the angle in the opposite arc. So angle ATB equals angle ACB. Therefore, angle ACB is 70 degrees. That's a one-line reasoning in the answer. State the tangent chord theorem, mark the equal angles, and write the value. That's the kind of neat, bankable mark examiners like. Section 2. Exam technique. Here's where the marks are and how to secure them. For geometry questions, you'll often see M1 for a correct method step and A1 for the final answer. Example. In the tangent chord question I just gave,
M1 is earned by stating the tangent chord theorem and showing the equal angles. A1 is the correct numeric answer. If you can't get to the final number, write down the theorem and the equal angle relationship. That's usually an easy method mark. Always label your diagram. Mark arcs, chords and radii with small tick marks or letters. Examiners love a clear diagram because it shows your reasoning even if arithmetic slips.
When to state the theorem explicitly, do it when the question mixes facts. For instance, write, by angle in a semicircle, the angle is 90, or by the tangent chord theorem, the angle between a tangent and a chord equals the angle in the opposite arc. A short labelled sentence like that wins method credit, and if a question asks prove or show, that explicit statement is expected. If you run out of time, leave the diagram with your marks and a one-line theorem statement. Examiners can award M marks from that alone.
Section 3. Quick Win and Practice. Quick Win. A 3-step, 10-second checklist you can use every time. Step 1. Draw and label. Always include the center O and mark diameters. Step 2. Mark equal arcs or chord relationships with small hatch marks and note which theorem applies. Angle in semicircle, equal subtended angles, cyclic opposite sum, or tangent radius. Step 3. Name the theorem aloud and write it down briefly in your answer. Repeat. Draw, mark, name. Do that and you catch the majority of careless mistakes. Try it now on a single past paper question and time yourself for 60 seconds.
Practice walkthrough. Apply the checklist to a short past paper style problem. Question. In circle with center O, AB is a diameter and CD is a chord meeting the circle at C and D, so that arc ADC is 120 degrees. Find angle ACD. Using our checklist, draw and label O, A, B, C, D. Mark arc ADC as 120. Recognize that angle at the circumference is half the angle at the center, so angle ADC equals half of 120, which is 60. Then angle ACD. If A is at the end of the diameter, angle ACB would be 90, but here we're focused on the triangle formed. Use the known angles to find the required angle and write the reasoning. The examiner wants the half arc step shown, a labelled diagram and the final value. That's M1, A1.
Common pitfalls in 30 seconds. 1. Mislabeling center and circumference. Always mark O for the center and show radii. 2. Confusing angles at the center with angles at the circumference. If in doubt, ask yourself, is this angle looking at the whole arc from the center or from the edge? 3. Assuming a tangent without proof. If a line is called a tangent, state it and give the tangent radius justification or show equal angles. Correct those 3 and you rescue a lot of lost marks.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable checklist at jcacademyonline.co.uk. Download the 5-page Circle Theorems pack and practice with the timed questions.
Outro. 1-sentence recap. Think arcs, half the center, mark the diagram, name the theorem. Visit jcacademyonline.co.uk for the printable pack. Stay curious.